All right, now, what we're going to do in this video is we're going to look at actually using the derivative to find the slope of the graph of a function at a given point. And then we'll also look at finding the equation of the tangent line to the curve at a given point. Okay? So we're just applying, now that we know how to do a derivative, we're thinking about something we can use it for. Okay? All right, so what you're going to start with is finding the derivative, but you sometimes have to rewrite, and this one is not looking like a power function, so I'm going to rewrite that second term as negative 4t to the negative 1 power. Now make sure you're keeping yourself straight about when you're rewriting and when you are actually finding a derivative. So don't do the derivative of one piece while rewriting the other. Just this, I'm still rewriting. It's an f of t. Now I'm going to do the derivative. And the derivative of 2 would be 0. And the derivative of the next term, I would have the negative 4 times negative 1, and then t to the negative 1 minus 1. Okay, so I wind up having positive 4t to the negative 2, which is the same as 4 over t squared. The negative 2 only applies to t, so only the t to the second power moves to the denominator. Okay. All right, now you're done doing the derivative, but here's the idea. The derivative is a formula that would allow you to figure out what the slope of the curve would be at any point on the original function. And so they've given us that they want to know what the slope would be at the point 4, 1. And we know that this is a formula that gives us the slope. So it's truly going to be a matter of you taking what you just found and then figuring out what the slope is when we're at the point 4, 1. So the input there is the 4. So that would be the t. That's the t. And the 1 would be the f of t, right? So you plug in the 4, okay, into the derivative formula, and you work it out. And so you get a 4 over 16. You get a 1/4. That would wind up being the slope when you're at the point 4, 1. Now you'd get a different number if you were at some other point on that original function. Okay. All right, here's another example. Oh, and we're just being asked for slope. So when we get that, we're done. Okay. Sometimes people do more than they need to. They didn't ask for an equation. They just asked for the slope. Okay. All right, now on this one, we don't know the chain rule yet, and so we'll do a little rewriting. I'll take that and I'll think about this x minus 4 squared. Remember, that's x minus 4 times itself, and I'll just work that out. So that's x squared minus 4x, and another 4x would be minus 8x plus 16, and I'll go ahead and distribute the 2 all the way through, and I haven't even started the derivative yet. That's all my rewrite step. Okay, now I'm going to start the derivative, and I have many power functions. So 2 times 2 would be 4x would be the derivative of the first term, minus 16 would be the derivative of the second one, and then the derivative of 32 would be 0. Okay. All right, so now I'm ready for the next part. So here's the derivative formula, and that gives me a way of finding out what the slope is at any point on the original function. All I got to do is plug in 2 and see what the slope turns out to be. And I see that when I'm at the point 2, 8, the slope of the curve is going to turn out to be negative 8. Okay, this one's easy to graph. This is a parabola. It's just touching the curve right here. All right. So if I were over at 3, I'd be there. Over at 5, I'd be here. It's going to look something like that. That's the graph of y equals f of x. And then the point 28 would be over here. Well, let me let that go up a little further. So that would keep going, all right? So that would go up a little further. And when you're at 2, 8, okay, so the point 2, 8, you want to know the slope of that, okay? It's hard. I have to write on this screen in a funny way, so my writing's never quite as good as I would like. So 2, 8, and then there is what I'm looking for. I'm trying to make that look like it's just touching the curve in one point, and what we found is the slope at that spot was -8. But like if I found what was the slope when I'm over at 5, then I'd plug a 5 in to that formula and I'd get something else, and what it would represent is what's the slope when I'm over here. Over here where the x was 5, then the slope would have been a +4. Okay? All right. Now, one more thing you could be asked to do is to go on and get the equation of the tangent line. So instead of just getting what the slope of the tangent line is, what the slope is, actually going on and getting the equation for the line that's tangent to the curve at that point. So it just really adds one step to the process. So first let me rewrite this so it looks like a power function. So this would be 2x to the -3/4 power. So the 3/4 came from the radical in the denominator. Remember how the root is the bottom number. And the reason there's a negative on it is the negative would have been what forced it to be in the denominator. Okay? All right, now once you've done that, you're ready to actually do the derivative. So that would equal 2 times -3/4 times x to the -3/4 minus 1. Okay, now clean that up. And this one doesn't clean up very well. So 2 times -3/4 would be -3/2. And then -3/4 take away 4/4 would be -7/4. Okay, so your derivative turned out to equal a -3/2, and then you have the 4th root of x raised to the 7th power. And it's in the denominator because it had a negative on it. Okay, so that's the formula that would give us, that's the formula for finding the slope anywhere on the function f. But I want the slope at an x of 1 because of that given point. So I'm just going to plug in a 1. Okay, so think about that. So you'd have -3/2. Then the 4th root of 1 would be 1. And when you take 1 and raise it to the 7th power, you get 1. So you wind up with -3/2 at that point. Now, in the earlier problems, we were done. But on this question, they asked us for the equation of the tangent line. Well, that -3/2 is the slope at -3/2 is the slope of the function at the point 1, 2. So all we have left to do is writing the equation of the line. Okay, so if you just came out of pre-cal, you probably remember the point slope formula or vaguely recall using it. You can do that, or you can just use y equals mx plus b, but you got to get back up to speed on how to do that. So it's really just a matter of, one way to do it is just to plug into the point slope formula. Slope goes in for m, and then the point had an x of 1 and a y, and that's like a specific point, so that's the x1, and then the y one would be 2. So keep the x with x, keep the y coordinate with the y, and then just simplify. So that'd be negative 3/2 x plus 3/2. And then you'll typically want to leave it in slope-intercept form for me. So we'll add 2 to both sides. Right, so I'm adding 2 here and here. And when I add 2 to 3/2, I get 7/2. 4/2 plus 3/2 would be 7/2. And this one wanted the equation of the tangent line. And so your equation would have been that. Okay, was the slope negative? Yeah. Okay, so I'm just double checking. Let me look at it again because I had something different last time. Oh yeah, that's a negative. So because of that negative, we did have the slope turning out to be negative 3/2. Okay, so that looks correct. Okay. All right, now one more question you can do once you know what a derivative is you can think about how to figure out where the graph of a function might have a horizontal tangent line. So where that's going to be helpful is when you have polynomials, like this one turns out to be just a quadratic. This one turns out to be a cubic of some sort, so it might do something like that. And if they're asking you for where it has a horizontal tangent line, then that means you're looking for where, if you tried to draw a line that was tangent to the curve and just touching the curve in one point, it's always going to happen at the mins or the maxes, the highs or the lows. So this is going to wind up having an important application later when you're trying to maximize or minimize something. You're often going to be asked to do this. So think about horizontal lines. Isn't the slope of that going to equal 0? Okay, aren't the slopes of these horizontal lines going to be 0? Right? So basically, when you see this question, you think, horizontal tangent line means you need the slope to equal 0. Okay, and that kind of tells you what your process is going to be. You're going to do the derivative. Okay, then you want to know where is the derivative equal to 0. That's what you want to know. And so the derivative would equal 0 at an x of 0. Okay, and then if they ask you for points, a point, so it's like this would actually be a graph that would be up here at 9 and just sitting there like that. All right, what you just found is that the horizontal tangent line would happen when x is 0. Now we need to figure out what the y is that goes with it. So we go back to the original function and we plug in the 0 and we get 9. So the point would have been 0, 9. Okay. Right now, if I tried that on this one, I would first want the derivative, which would be 3x squared plus 1. Okay. Oh, but if I try to find out what causes that to equal 0, there's no number that's going to wind up making that equal to 0. When it's cubic, you kind of think that it could look something like that and have some highs or lows. But in this case, I wind up noticing that no matter what I put in for x, once it's squared and multiplied by 3, that's going to have to be 0 or positive. There's no way. Like, if you continue trying to solve this, okay, something squared can't be negative. You can't get a real number out of that. So there'll be no horizontal tangent lines for that. Okay. Let me pull up Desmos real quick and I'll end the video with a picture of what the graph looks like. Okay. All right, so if I graph x to the third plus x, it doesn't actually form a true turning point. It just kind of has an inflection point right here, right there. So it doesn't really have any horizontal tangent lines, is what we found. Now, section 3.1, you're going to revisit section 3.1. You're going to do the homework for 3.1b, but all it really is what we were doing on this page, finding the slope and getting the equation of tangent lines, okay? I don't even think it includes the horizontal tangent line situation, though I don't remember. It's just when you go back to 3.1, you really won't have to use the limit process. You'll be able to go back and just use the shortcut rules.